In last video, we discussed about electric field, electric force, current, voltage and power. In this video, we are going to discuss about the Ohm's law, relation between current and voltage, and the resistors in series and parallel combination. Ohm's law is the foundation of electrical engineering. If you are studying engineering in future, and especially if you are studying electrical engineering in future, then you are going to use this law very frequently because this law relates current and voltage together. So what is Ohm's law? Ohm's law. So as I said, Ohm's law establishes the relation between current I and the voltage V. So imagine we have a simple circuit here. This is a resistor and here is an ammeter. This ammeter is connected with a switch. This is power supply and here is a rheostat which will change the current flowing in the circuit, and this rheostat is a very simple variable resistor. It means you can change the resistance of this thing which you can see here, and it's called as RH. It means this is a rheostat, and you can change the resistance of rheostat by using by actually moving the knob over it. Now if we want to measure the voltage across this resistor, then we need to connect the voltmeter with it. So this is a voltmeter, and one important thing related to circuit before we proceed further, you can see this is ammeter, and ammeter is always connected in series. So ammeter is connected in series with the resistor or with any electrical component, because in parallel it will not work. Instead, if you are connecting ammeter in parallel, it will act as a good conductor and it will short the circuit. So, and another important thing here, this voltmeter is always connected in parallel to either resistor or fan or any other electrical component. If you want to measure voltage across any electrical component, then this voltmeter is connected in parallel. So right now the situation is that this switch is open. When the switch is open, no current flows in the circuit. No current. Now what I'm doing is I'm closing this switch. The moment I will close the switch, the current will start flowing in the circuit like this. Let's say this current is I at this moment. Because when the switch is closed, depending on this resistance of the rheostat, the current will start flowing in this circuit, something like this, and the ammeter will show some value of current. If we make a table here, then we can write the current, and you can take it either in milliampere or ampere depending on the capacity of your circuit. And this is the voltage across the resistor in volts. initially when the circuit is open, no current flows and there is no voltage. But once you will close this switch, the current will start flowing in the circuit and there will be some voltage which will appear across this resistor R. So let's say that voltage is 1 volt and current is 0.1 milliampere. I'm just randomly taking this value. And you can observe this thing practically when you will be doing practical in your physics lab. Now decrease the resistance of this rheostat so that more current can flow through this circuit and through this resistor. Now when you decrease the resistance of this rheostat, but make sure that the resistance of this resistor remains constant. You are not supposed to change this, but you can change this because you are measuring voltage across resistor R, not the voltage across rheostat. So when you will decrease the resistance, more current will flow and the voltage across this resistor will increase. So let's say the voltage across this resistor is 2, then current will be around 0.2 milliampere in this ammeter. And I have written ammeter, and when I'm using milliammeter, I should write here milliammeter because then it's easier to measure the current by using milliammeter if you are using the unit as milliammeter. Now again, if you will decrease the resistance of this rheostat, current will increase, and you can keep doing that, decrease the resistance of the rheostat and current will increase. So let's say if this is 3, it will be 0.3. If this is 4, it will be 0.4, something like this. What you can see here, if you increase the voltage, it means earlier 0, then 1, then 2, then 3, then 4, then the current is also increasing. With increase in voltage, current is also increasing. So what we can say is V is directly proportional to I. It means if you will increase the voltage, then the current will increase, or you can say if you are increasing the current in this circuit, then the voltage across this resistor will increase. So V is proportional to I and V is equal to Ri. What I'm doing, I'm replacing this proportionality sign with a constant. And what is this constant? This constant is the resistance of this resistor. And this is the Ohm's law. Now you are getting a relation, and this is called as Ohm's law. And Ohm's law says that the voltage is directly proportional to current, or V is equal to Ri. By using this formula, we can find the resistance of the resistor which is used in this circuit. And let's say the resistance of the resistor is R, then we can write R is equal to V by I. The unit of voltage is volt and the unit of current is ampere. So we can write the unit of R is volt ampere power minus 1. But a more frequently used unit, which you will find everywhere in your textbook or in your syllabus, and it would be written as unit of R is ohm. It's read as ohm after the name of George Simon Ohm. So this symbol is called as ohm. Now if I draw a graph of this voltage which is V, voltage V, and the unit is in V, and here current is I and the unit is milliampere. Now if you draw a graph, you will get a straight line something like this, and this straight line shows that the voltage and current they are directly proportional. If this line is curved something like this or like this, it means the voltage and current are not proportional to each other. So these lines, they do not follow Ohm's law. They do follow Ohm's law? No, they do not follow Ohm's law. This one also do not follow Ohm's law. But this line, since it's a straight, this will follow Ohm's law. So I can say here that Ohm's law is not valid. Here valid. Here not valid. So when the line is curved, in case of voltage and current relation, then the Ohm's law is not followed. And in that case, the material across which you are measuring the voltage will be called as non-ohmic. And the material which will show this characteristic, it means voltage and current, they are directly proportional, they will be called as ohmic. So if I rub this, give me some time, I will rub this. Ohmic and non-ohmic. So ohmic are the materials which follow the Ohm's law. It means if you apply voltage across the material and current is flowing through that material, then they will show the direct relation between current and voltage. So the materials which show the direct relation between current and voltage, they are called as ohmic. And the materials which do not show this relation, it means they do not follow Ohm's law, they are called as non-ohmic. It means current and voltage will not be proportional in case of non-ohmic materials. Now after this, let's discuss about the series and parallel combination of resistors. Series and parallel combination of resistors. Actually, this series and parallel combination could be for resistors, capacitors, or cells as well. But right now we are focusing this series and parallel combination of these resistors. So when we talk about the series combination, so you can understand series combination like when you stand in a queue. So students are standing one after the another, one after the another, one after the another. That is a series combination. So imagine there are resistors like this. This is R1. There is another resistor. This is R2. And there is another resistor. This is R3. So this type of setup is called as series. And it's not necessary that if they look like this, then only it will be series. To understand what is series and what is parallel, you can use here this method. There are two hands of the resistors. Imagine my body is a resistor, then I have two hands like this. One hand, another hand. If my one hand is joined with another resistor and this hand goes to any other resistor, not to the same resistor, then I am in series with those two resistors. So you can see here, let's say this is arm1 of this R1 and this is arm2. Now for this R2, this is R1 and for R2 this is R2 and this is R1, this is R2 for R3. So if I just separate this for a second, so what happens? Now they all are independent with each other. If you connect them together, something like this. So what you can see, second hand or second arm of R1 is connected with the first arm of R2. Now second arm of R2 is connected with the first arm of R3. And the second arm of R3 is free. Now this can go to any other resistor, or it can go to a power supply or a meter or any other thing. That is called as series combination. And now, because we want a complete circuit, so what I'm doing is I'm connecting it with a power supply. And if you want to measure current, I'm connecting it with a meter as well. And if you want to control the current as well, or you want to switch on and switch off the circuit, I will connect one switch as well here. And this is series combination. One more thing to remember: series combination, right? In series combination, when the switch is closed, the current which flows in this series combination, that remains constant throughout this circuit until and unless you change either of the resistors or all the resistors. So if I is the current entering from here, same will be current here, same will be current here, and same will be current here. But one thing will be different, and that is voltage. Voltage across R1 will be different, but here also it's not necessary that it's always different. Voltage will be different if the resistance of each resistor is different. So the voltage across R1 could be V1, voltage across R2 could be V2, and voltage across R3 could be V3. And when we combine this V1, V2 and V3 with each other, what we will get? We will get V, voltage of this power supply. V is equal to V1 plus V2 plus V3. It's very much like you are giving 10 rupees to someone. That person can distribute 10 rupees in any proportion. But until and unless that person is having his or her own money, they cannot distribute more than what they are getting. So the total voltage across each resistor combined is going to be equal to the voltage of the power supply. So now if I write V is equal to V1 plus V2 plus V3, then I can write here by using Ohm's law. By using Ohm's law. What is Ohm's law? V is equal to IR. So I can write IR is equal to, similarly, V1 is equal to IR1. Why I am taking I always I? Because current is same everywhere. So I can write IR1 plus IR2 plus IR3. Now take I common. If you take I common, you will get IR is equal to IR1 plus R2 plus R3. So what you can see, current will get cancelled. Current will get cancelled. And what is left? You will be left with this RS, resistance in series. Or you can say the total resistance in series is equal to R1 plus R2 plus R3. Now, what about the resistance in parallel? So parallel means when both the hands of the resistor are connected with some other resistor. This is a very simple explanation. There can be a complex circuit combination, but for simplicity, both the hands of the resistor, let's say this is R1 and this is R2, and 1 and 2 and 1 and 2, and this is R3. You can take many more, but simply we are taking R1, R2, R3. Now when both the hands of the resistors are connected with each other, so let's say one is connected with 1 and one is connected with 2 is connected with 2. Again here 1 is connected with 1, 2 is connected with 2. So this is the parallel combination. Now in parallel combination also you want to give some energy to the circuit, and how we can give energy to the circuit? By connecting it with a power supply. You can connect a meter also to measure the current. Let's say if I'm connecting a meter here, so it will measure current. You can connect a switch also like this circuit, but I'm not going to do that. You can do that, you can improvise while doing that. So the important thing is, when the circuit is closed, current will flow in this circuit and I current will flow in this circuit up to this point. It's like water is flowing in a single pipe, and after reaching here, this water pipe is connected with 3 other pipes. So the water in that pipe will get divided into 3 parts. But it's not necessary that all the 3 pipes which are connected here, here and here, they may be using the water, because one pipe may have its tap open, another pipe may not have its tap open, it may be closed. So similarly, tap could be related with the resistors. So depending on the resistance of the resistor, the current in the water will get distributed. And see, in a flow here I have written R4, it should be R3. So, but that doesn't matter, because R4, R5, anything I can write as long as I'm naming it properly. So the current I which is flowing here and reaching at point A, that will get divided into 3 parts, and let's say that is I1, I2 and I3. Same current I3 will reach here, I2 will reach here, I1 will reach here, but again once they will combine, they will become is equal to I. So what you can see here that I is equal to I1 plus I2 plus I3. Now, second thing, all the ends of these resistors, if you see carefully, they are directly connected with the power supply. Though they may be taking a long route, but they are directly connected with the power supply. So they all will get same voltage. They will get same voltage. So voltage across R1 would be V, voltage across R2 will be V, voltage across R3 will also be V. So in parallel, you can write in parallel, voltage remains same across all the resistors in parallel. So now again, by using Ohm's law, I can write, because Ohm's law says that V is equal to IR, so I is equal to V by R. Similarly, I1 is equal to V by R1 and I2 is equal to V by R2 and so on. So I can write here V by R is equal to V by R1 plus V by R2 plus V by R3. You can see V is common in all the positions. So what I can do is I can cancel this V by taking them common, and you will get 1 by Rp. P for parallel. So resistance in parallel would be is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the formula for resistance in parallel, and this is the formula for resistance of the resistors in series. In next video, we will solve some questions related to the resistors and the combination of resistors.